I'm Anil Kumar. Welcome to my series on rate of change. I'm sharing with you some thinking and communication questions based on previous test papers. The question here is, the given point is either a maximum or a minimum on the function. Verify using rate of change and explain your solution. So we have two examples here. Point minus 1, 2 on the function x cubed minus 3x. The other one is point minus 28 on f of x equals to 2x cubed plus 6x squared. So the first function, you could actually factor x and write this as x squared minus 3, right? So we get 3 roots here at 0 and plus minus square root 3. So you notice that this particular function will have a graph which will be kind of like this, correct? So I'm trying to explain you the concept first, and then we'll get into the solution, right? So 1, 0 is at x equals to 0, right? The other two are at square root of minus 3, square root 3 minus value, and square root of 3 plus, right? So these are your 3 zeros. We are given a point minus 1. We do expect local maximum at this point, and the reason being that if you look at the tangent before and after, it changes from increasing to decreasing from the graph, right? So that is the whole idea. So we are going to analyze the preceding and following rate of change, right? To justify whether it is a maximum or a minimum, right? Local maximum or a minimum. Is it clear to you? Okay. So what we will do here is, since we are interested in minus 1, let's calculate the value of the function at minus 1. So if I substitute here minus 1 cube minus 3 times minus 1, I get minus 1 plus 3, which is equal to 2. Now a point on the, let's say this is minus 1. So point on the left side will be minus 1.1, correct? So we get minus 1.1 whole cube 3 times minus 1.1 equals to. And then on the right side of this, we'll use a point which is f of minus 0.9, correct? So minus 0.9 whole cube minus 3 times minus 0.9. So let's use the calculator to find these values. So within brackets we have minus 1.1 whole cube minus 3 times within brackets minus 1.1. This value is in decimals. Let's write down 1.969. Positive, right? Now I'm going to change this value to minus 0.9, okay? So if I change this to minus 0.9, then what do we get? 0.9 equals to. So we get a decimal value which is equal to 1.971. Okay, so we do get these two values. Now we'll find rate of change from left and right, right? So instantaneous rate of change from left, that is to say, we are considering now this point on the left side, right? So we'll say f of minus 1.1 minus f of 1 over minus 1.1 minus 1, right? So we'll calculate this value now. So which is equal to, we already calculated this as 1.969 minus f of 1, which is 2, divided by, so here we get, so minus of minus 1, I'm sorry. So you add 1, so you get minus 0.1, correct? So let's calculate this value. We have 1.969 969 minus 2, which is equal to, and we are going to divide this by minus 0.1. So that gives you in decimals 0.31, right? So that gives you 0.31. So that is the positive slope, right? So it is positive. So it confirms that on the left side it is increasing, right? So that means the tangent is increasing. It's kind of like this. Clear? Now let us also find the instantaneous rate of change from the right side. So let me write like this. Instantaneous rate of change from the right. So we have considered this point, which is f of minus 1 minus f of 0.9 minus over minus 1 minus 0.9. Correct? So that is from the right side. So we are considering this. And we have calculated the value as 2 minus, this value is at 1.971 divided by, so this is negative 0.1, correct? So that should give you, let's use the calculator once again. So we get 2 minus 1.971 and divide this by within brackets minus 0.1. Decimal value is minus 0.29, right? So approximately 0.3. Correct? So we get that value. Negative clearly indicates that it is decreasing, right? Correct? So what we see here is that the instantaneous rate of change at x equals to minus 1 is the average of these two, right? Is the, well, this is negative, is the average, is equal to average, right? Average value. So which is 0.31 minus 0.29 over 2. So we have 0.31 minus 0.29 equals to, divided by 2 equals to, in decimals, it gives us 0.01, which is almost 0. Is it clear to you? So the average value is 0. The instantaneous rate of change at x equals to 0 is 0. That means horizontal tangent line. So clearly, it indicates what? It indicates a maximum. Since the instantaneous rate of change changes from positive to negative. Clear? So if it is like this, we get a maximum. Is that clear to you? So that is how we are going to explain this particular question. And these are the steps involved. So I hope all the steps are perfectly fine. Now based on this, I'd like you to pause the video. Answer, we've already done A. I'd like you to do the same example. There's hardly any difference here. The calculation should be made as per the values given. The point is also at negative 2, so almost same calculations. So I'd like you to perform these calculations and verify that there indeed is a local maximum at this point, right? So which is minus 2.8. Perfect. So here we can end the video. Part B is for you to practice. So I hope that makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.